Hi guys, today we are going to see a good problem based on uh, GATE 2020. So this is question number 7 on paper 1. So the question is very simple. The stress state at a point in a material under plane stress condition is equibiaxial tension with a magnitude of 10 MPa. So if you take 1 unit on the sigma tau plane to be 1 MPa, then what is this particular stress state's Mohr circle representation? And you are being given 4 options, so you have to find out what is the answer and select appropriately. So before we begin to solve the problem, if you want to know more about how to draw a Mohr circle, you can check out Strength of Materials NPTEL lecture by Professor Sriman Kumar Bhattacharya from IIT Kharagpur, or any other videos that you are comfortable with. There are plenty of videos on this particular topic. So let's begin solving the problem. It is given that we are having a stress element with the equibiaxial tension, okay, with the 10 MPa, and our 1 unit on tau plane is 1 MPa. So let's just draw it. Before solving that problem, let's just see how to draw a Mohr circle in general. So let's say I'm having an element like this. Okay, so now let's say I'm having a stress state like this. So here let's say sigma xx, sigma yy. Okay, so here sigma yy, sigma xx. Now if I take shear, so let's just say shear state to be like this. Let's assume the shear state to be like this. So so let's just construct a basic Mohr circle for this particular stress state, which is very general. So let's say it is tau in general. So what we are going to have is your sigma plane and your tau plane. Okay, so first you plot what is sigma xx. So let's just assume that sigma xx is greater than sigma yy. So you'll get sigma xx, let's say here, sigma xx. Now let's say sigma yy. So let's assume it is here. So that is our sigma yy. Okay, so now let's try to plot tau. Now the general sign convention, let's say sign convention here, let me draw here. So if you are having clockwise rotation, so we'll take it to be positive. So if I take my axis, okay, my tau will be positive. This is where clockwise comes, and this is where my anti-clockwise comes, this particular thing. So if I consider here, so you can see that sigma yy, so the tau corresponding to that is actually anti-clockwise. So you're corresponding to this particular thing, your tau is going to be negative. Let's say this is the tau or minus tau, and corresponding to, let's just draw in blue. So now you're having something like this. So that means you are going to have blue color representing in clockwise direction. Okay, so let's just make it here once more, clockwise direction, and your green color, which is yy, it is in anti-clockwise direction, right? So this is negative and this is positive. So if I draw here my blue color, I'm going to get positive tau. Okay, now if I join these 2 points, I'm going to get some particular point of intersection, right? This is the center of my Mohr circle. Yeah, okay. So now I take this as the center. So let me just do it in another color. So I take this as the center and try to draw an arc with this particular radius. So let's use this. So I'll get a circle in this way, a rough circle. I'm sorry about the circle shape. Yeah, so this is how you actually draw a Mohr circle. So why I'm trying to explain this is here is most of the problems related to Mohr circle are actually easy if you draw it than using a formula. So it's better to draw everything and see it since it's very easy to draw. So now let's try to draw. Let me just zoom out from here a bit. Yeah, let's try to draw a Mohr circle for the particular state given. Okay, so what are we given here? We are given a, okay, let's just use this. Yeah, so we are given a state like this, and you are given that it is biaxial and equibiaxial. Okay, and nothing is given related to tau, so tau you can take it to be 0. So now if you draw this according to the method loop. Okay, so first I'll draw this. Let's say here is my tau. Okay, here is my sigma, and now I'll draw this. So this I'll get to be again at this point. Both will be at this point actually, sigma xx and sigma yy, and tau is 0. This means what? My radius, uh, not basically radius. Yeah, in this case it will be a radius of Mohr circle in this particular case only, because they are equal. The radius is going to be 0. So therefore, what is my final answer? My final answer, it's actually a point at some distance sigma. Now, what is my given sigma actually? My sigma is given to be 10 MPa. If you see, it's equiaxial. So what is my final answer? So let's just zoom in again. So it's actually a point on sigma axis at a distance of 10 unit. So B is my right answer. I hope you understood this problem, and you can check out the videos related to Mohr circle. So my suggestion is you always try to draw it and solve no matter what, because it gives you a physical um, sense of what Mohr circle is, and you don't have to remember formula each time the condition changes, and it becomes very easy to solve. So all the best. Thank you.